What is ray tracing, and how does it enhance game graphics? Understanding ray tracing. Ray tracing is a rendering technique used in computer graphics to simulate the way light interacts with objects in a realistic environment. It traces the path of light rays as they travel from a light source, bounce off surfaces, and reach the camera or player's viewpoint. This process creates lifelike reflections, shadows, and lighting effects, which enhances the overall visual quality of video games and movies. Realistic lighting and shadows. One of the primary ways ray tracing enhances game graphics is through its ability to create realistic lighting and shadows. In traditional rendering, shadows and lighting are often pre-calculated or simplified, leading to less accurate effects. Ray tracing simulates how light behaves in real life, including how it bounces off different surfaces, creating soft, natural-looking shadows and reflections. This results in more immersive and convincing environments. High-quality reflections. Ray tracing is particularly known for its ability to produce high-quality reflections. Unlike traditional methods, which might only reflect specific objects or use simplified techniques like screen space reflections, ray tracing simulates reflections based on the full environment. For instance, players can see themselves reflected in a pool of water or the windows of buildings, with the reflections behaving dynamically as the scene changes. This level of realism can drastically improve the visual experience in a game. Enhanced global illumination. Global illumination, GI, refers to the way light bounces and scatters throughout an environment, affecting how colors and shadows appear. Ray tracing can simulate GI in a much more accurate way, taking into account how light interacts with various surfaces and materials. This leads to more natural lighting that adapts to the scene's surroundings, creating richer and more atmospheric environments. Simulating transparency and refraction. Ray tracing also excels at simulating transparency and refraction, which is the bending of light as it passes through materials like glass or water. This allows objects in transparent surfaces to be realistically distorted and reflected. For example, looking through a glass window at a distant object would show the distortion caused by the glass, along with the accurate reflection of the surrounding scene. Real-time performance improvements. In recent years, advancements in hardware, particularly through graphics processing units, GPUs, have made real-time ray tracing a possibility for modern games. While ray tracing is computationally intensive, newer GPUs from companies like NVIDIA and AMD have incorporated dedicated ray tracing cores, enabling real-time rendering of ray-traced effects. This allows games to look more realistic without sacrificing performance, although it still demands powerful hardware. Depth and dimensionality. Ray tracing enhances the depth and dimensionality of a scene by simulating the complex behavior of light in 3D space. This makes objects and environments appear more tangible and realistic, with light interacting in ways that feel natural. It gives objects a sense of weight and presence, making them appear more integrated into the virtual world. Improved visual fidelity in reflections. In addition to reflections on flat surfaces, ray tracing allows for reflections on curved or irregular objects, enhancing the overall realism of scenes. Whether it's the reflection of a character in a puddle or an intricate reflection on a metal surface, ray tracing captures these details with a level of fidelity that was previously unattainable in real-time graphics. Creating immersive environments. Ray tracing's ability to create accurate and dynamic lighting effects has the power to transform game environments. It adds a level of realism that allows players to feel more immersed in the virtual world. For instance, realistic lighting during different times of day, or the interplay of light and shadow in dark, moody settings, contributes to a game's atmosphere, making it feel more authentic. Future of ray tracing in gaming. As ray tracing technology continues to evolve, its applications in gaming are expected to expand. Developers are pushing the boundaries of how ray tracing can be used to enhance graphics in real time, incorporating more advanced features like ray-traced shadows, ambient occlusion, and even ray-traced particles. As hardware capabilities improve, ray tracing will become an increasingly integral part of the gaming experience, further bridging the gap between virtual and real-world visuals.